unit substation typically requires a main disconnect ahead of the transformer within the substation itself. This is a critical safety measure. The main disconnect serves as the primary means of isolating the transformer and the downstream electrical equipment from the power source, ensuring a safe working environment during maintenance and emergencies. The purpose of a disconnect is to provide a readily accessible point to energize the equipment. Having a disconnect located directly within the unit substation streamlines the process of isolating the equipment for maintenance or repairs. This minimizes downtime and reduces the risk of electrical hazards. Even though the existing 4160-volt switchgear section that feeds the unit substation already contains a disconnect, its location 40 feet away and out of sight introduces a potential safety concern. A disconnect within the unit substation itself provides a convenient and accessible point of isolation closer to the transformer. This ensures quicker and safer operation during maintenance or emergencies. Without a local disconnect, personnel would need to travel to the remote switchgear to energize the transformer, which adds time and complexity to the isolation process. This is particularly problematic in emergency situations where a rapid shutdown is required. The National Electrical Code, or NEC, provides guidelines and requirements for electrical installations, including disconnects for transformers and substations. Although the specific requirements may vary depending on the application and voltage level, the NEC generally emphasizes the importance of having a readily accessible disconnect to ensure safety. Relevant NEC sections to consider might include those covering transformer overcurrent protection, disconnecting means, and general requirements for electrical safety. The requirement for a disconnect ahead of the transformer is based on safety standards and best practices in electrical engineering. It is not simply a matter of convenience, but a fundamental requirement to protect personnel and equipment from electrical hazards. Here's a more detailed breakdown of the key considerations. Firstly, safety is paramount. A readily accessible disconnect ensures that qualified personnel can quickly and safely de-energize the transformer and downstream equipment in the event of an emergency, such as a fault or fire. Secondly, maintenance is critical. Routine maintenance testing and repairs are essential to ensure the reliable operation of the unit substation. A local disconnect allows maintenance personnel to safely work on the equipment without having to rely on a remote disconnect. Thirdly, NEC compliance must be adhered to. The National Electrical Code provides specific requirements for disconnects, including the location, type, and rating. Ensuring compliance with the NEC is essential for safety and code enforcement. Fourthly, operational efficiency is important. A local disconnect simplifies the process of isolating the transformer for maintenance or repairs, which can reduce downtime and improve operational efficiency. Fifthly, risk mitigation helps prevent electrical hazards. A local disconnect minimizes the risk of electrical shock or arc flash, which can cause serious injuries or fatalities. Sixthly, coordination with upstream protection is necessary. The disconnect should be coordinated with the upstream overcurrent protection devices, such as fuses or circuit breakers, to ensure that the transformer is properly protected from overloads and short circuits. Seventhly, documentation and labeling are required. The disconnect should be clearly labeled to indicate its function and the equipment it serves. Proper documentation and labeling help prevent confusion and ensure that personnel can quickly locate and operate the disconnect in an emergency. Eighthly, training is essential. All personnel who operate or maintain the unit substation should be properly trained on the location, operation, and purpose of the disconnect. Adequate training helps ensure that personnel can safely and effectively respond to emergencies. In summary, the requirement for a main disconnect ahead of the transformer in the unit substation is a fundamental safety requirement that should not be overlooked. It provides a convenient and accessible means of isolating the equipment for maintenance and emergencies, reducing the risk of electrical hazards and ensuring the safety of personnel and equipment. Now let's consider some of the specific aspects of selecting and installing a disconnect for a unit substation. The disconnect should be sized appropriately for the transformer's primary current rating. This ensures that it can safely interrupt the full load current of the transformer without being damaged. The disconnect should be rated for the voltage of the 4160 volts system. This ensures that it can withstand the electrical stresses of the system without failing. The disconnect should be selected based on the specific application and environmental conditions. Factors to consider include the type of enclosure, the operating temperature, and the presence of corrosive substances. The disconnect should be installed in accordance with the manufacturer's instructions and all applicable electrical codes. This ensures that it is properly wired and grounded, and that it meets all safety requirements. The disconnect should be clearly labeled to indicate its function and the equipment it serves. This helps prevent confusion and ensures that personnel can quickly locate and operate the disconnect in an emergency. The disconnect should be inspected and tested regularly to ensure that it is in good working order. This helps identify any potential problems before they can cause a safety hazard. Some additional points to consider include the type of disconnect to use. Options include fused disconnects, which provide both disconnecting and overcurrent protection, and non-fused disconnects, which only provide disconnecting means. The choice depends on the specific application and the requirements of the electrical system. The availability of space within the unit substation for the disconnect. In some cases, space may be limited, which could influence the type and size of disconnect that can be used. The need for remote operation of the disconnect. In some cases, it may be desirable to be able to operate the disconnect remotely, which would require a motorized disconnect switch. The coordination of the disconnect with other protective devices in the electrical system. The disconnect should be coordinated with the upstream and downstream protective devices to ensure that it operates properly in the event of a fault or overload. The specific requirements of the local electrical utility. The utility may have specific requirements for disconnects that must be met in order to connect the unit substation to the grid. In addition to the safety and operational benefits, having a main disconnect ahead of the transformer can also provide benefits in terms of compliance with insurance requirements. Many insurance companies require that electrical equipment be installed and maintained in accordance with the National Electrical Code and other applicable standards. Having a main disconnect ahead of the transformer can help demonstrate compliance with these requirements, which can reduce insurance premiums and improve the overall insurability of the facility. Furthermore, it is crucial to conduct a thorough arc flash hazard analysis of the unit substation. An arc flash is a dangerous electrical explosion that can occur when there is a fault in the electrical system. The arc flash hazard analysis will identify the potential arc flash hazards and determine the appropriate personal protective equipment, or PPE, that personnel must wear when working on or near the equipment. The analysis will also help determine the appropriate settings for the overcurrent protection devices to minimize the arc flash hazard. The main disconnect can play an important role in reducing the arc flash hazard by providing a means of quickly de-energizing the equipment in the event of a fault. This can help limit the duration of the arc flash and reduce the severity of the potential injuries. The installation of a main disconnect should be performed by qualified electrical personnel who are familiar with the NEC and other applicable standards. The installation should be inspected and tested by a qualified electrical inspector to ensure that it meets all safety requirements. Regular maintenance and testing of the disconnect are essential to ensure that it remains in good working order. This includes visual inspections, mechanical testing, and electrical testing. Any problems that are identified should be corrected immediately to prevent a potential safety hazard. Finally, it is important to document all aspects of the disconnect, including its location type, rating, installation date, and maintenance history. This documentation will be helpful for future maintenance and troubleshooting, and it can also be used to demonstrate compliance with insurance requirements. In conclusion, the requirement for a main disconnect ahead of the transformer in a unit substation is a critical safety measure that should not be overlooked. It provides a convenient and accessible means of isolating the equipment for maintenance and emergencies, reducing the risk of electrical hazards and ensuring the safety of personnel and equipment. By following the guidelines and recommendations outlined above, you can ensure that the disconnect is properly selected, installed, and maintained, and that it provides the maximum level of protection for your facility. Remember that electrical safety is everyone's responsibility. By taking the necessary precautions and following the applicable codes and standards, we can all help prevent electrical accidents and injuries.